Tonight we're going to slow everything down and look at one of the strangest ideas in quantum physics: particles that behave like soft, gentle waves. Just get comfortable, let your mind wander, and let this story about tiny particles and quiet waves play in the background while you drift towards sleep. Tonight, we are going to think about something small and strange. Not planets, not stars, but single particles. Tiny bits of matter that are so small, you'll never see them with your eyes. Find a comfortable position. Let your shoulders drop. Let your jaw unclench. You don't have to remember any of this. You can just let it wash over you like waves on a quiet shore. Imagine one tiny particle. You can think of it as a little dot of light or a single grain of dust floating in the dark. In everyday life, we treat particles like little marbles. They have a position, a path, and a place they're going. But down at the quantum scale, that simple picture stops working. Our marble starts acting less like a tiny rock and more like a soft, spread-out wave. Imagine a wall standing in front of this particle. The wall isn't solid all the way across. It has two narrow openings cut into it, two slits. Behind the wall, there's a smooth screen that can catch the particle when it arrives. Whenever a particle lands, it leaves a little mark, like a soft glowing dot. We're going to send particles toward the wall, one at a time. Slow, gentle, calm. First, imagine the particle is only a particle, no wave behavior, just a tiny marble. If we cover one slit and leave the other open, the particles that get through will hit the screen in a single band, right behind the open slit. We uncover the first slit and cover the second, the band moves. It appears behind the other opening instead. So if both slits are open and particles are just marbles, you'd expect to see two bright bands on the screen, one behind each slit. Simple, predictable, comfortable. That isn't what the universe gives us when we open both slits and send particles one by one. The screen doesn't slowly fill in two simple bands. Instead, over time, it draws a whole pattern of many bright and dark stripes, a wave pattern, an interference pattern. Stripes where the wave is strong, dark gaps where the wave cancels itself out. Even though we send each particle alone, their impacts line up as if each one is spread out like a wave, gone through both slits and interfered with itself. That's the strange part. Each particle arrives as a single dot on the screen, but the probabilities, the chances of where it might land, are shaped like a wave that passes through both opening. It's as if the particle doesn't pick a single path in advance. Before we look, it behaves like a spread out wave of possibilities. Finally hits the screen, does it choose a single point, and the wave of possibilities collapses into one outcome. We say that particles have wave-particle duality. They are described by waves, but they show up as particles. Imagine we're curious and impatient. We decide to watch the particle as it passes through the slits. We place a tiny detector at the openings, something that can tell us. Did it go through the left slit or the right one? The moment we do that, the moment we insist on asking which path the particle took, the interference pattern begins to fade. Instead of many stripes, the pattern becomes more like two bands again, as if the particle has been pushed to behave more like a tiny marble. By measuring which slit it uses, we change the experiment. We change how the particle behaves. So what is the particle really? A little bead? A spread out wave? In quantum physics, we describe it with a wave function, a mathematical wave that encodes the chances of finding the particle here or there. Where the wave is large, the particle is more likely to appear. Where the wave cancels out, the particle almost never shows up. The pattern on the screen is like a shadow of that invisible wave, slowly revealed dot by dot, as many particles arrive. This doesn't match our everyday intuition. We're used to objects having one position, following one path, doing one thing at a time. But at the quantum scale, a particle doesn't carry a tiny hidden script for exactly where it must land. Instead, it carries a wave of possibilities spread out in space until an interaction or a measurement forces a single outcome. Physicists still argue about what this really means. Is the wave something physically real? Is it just a tool for predicting outcomes? Is there more than one world involved? For tonight, you don't have to decide. You can let the question remain open, like a book resting halfway closed on your nightstand. As you drift towards sleep, you can picture that quiet lab, a wall with two thin slits, a soft screen in the dark, and single particles arriving one by one. Each impact is a tiny decision, drawn from a gentle, invisible wave of possibility. Your thoughts, too, can spread out and soften until they settle. Let the details blur. Let the patterns fade into the background. You're safe. The experiment can keep running without you. Good night.